Okay, so if we have differential equation, obviously you can see this one, dy over dx or dy respect with variable x equals to sine of two variables x and y. Okay, so if you see like this, addition of two different variables, so we cannot do separable method. So what you should do, you have to assume first these two variables into single variables. Okay, so let's assume this as u variable, u, yeah, u, not x. Okay, just like that. Okay, so I'm gonna change now, and then this is over dx, it's moved to the right side and it's gonna be times dx move to the right side, and now it's only single left here, only dy equals to sine x plus y dx, and we change x plus y as u. Okay, so this is u. Now you have more looks simple equation now, and then dy here I'm going to change into u and x. Yeah, so I derivate each part on the left hand side and right hand side. So derivative of y dx, derivative of y dy, derivative of x is dx, and derivative of u du. And then I change the subject dy here, and as the subject dy, that's I mean, and this move to the right side is gonna make negative dx, move to the right side. So now I have dy equals, and then I change dy's, replace dy as this. So this dy I change here, and then sine of u dx. Okay, now you see into variables u and x, but you need to join on the same variable, like term it's into same variable. So I'm gonna move the dx here to the right side on here. So now only left here du, and then I have now sine u dx plus du. Sorry, dx, this dx. Okay, and I factorize into single dx. So divide dx. So now sine u plus 1. Okay, now you can integrate if you want, but not yet. If you want this, you move here, go ahead. Or you integrate both sides like this, go ahead. Okay, I'm gonna move this one. It's too crowded here. I'm gonna use another place. So I have before I have oops I have I have du equals to sine u plus 1 dx. Du equals to sine u plus 1 dx. So this is u and this is u. Better you join u with u. Now I move this to here, become division, right? Because cross multiply. This is over 1 actually. This is over 1. So this moves on here. Sine u plus 1 equals to dx. Now they already collected on the same variable u. Alright, now I have to do manipulation. So I'm gonna move this 1 over sine u plus 1, and this I put just here, equal dx. Before I integrate both sides, I'm gonna do another manipulation. If you remember, if the denominator like this, we try to avoid too much variables on the denominator at the bottom here. So let's find by multiply the conjugate of something. It means the opposite of the operation. So we want to multiply by the opposite of positive is negative. So 1 over sine u plus 1. So I will multiply here by sine u minus 1 over sine u minus 1. Or just use like this. So I want to make it 1 minus, not sine u minus 1, because it's gonna be negative. Better is 1. Why? Because I'm going to try to find closer to this. Sine square x plus cosine square of variable x is equal to 1, right? So I'm gonna put 1 minus something. So I'm gonna move here just 1 minus sine u. Because this actually 1 plus sine u. It's okay. So this is the conjugate operation. It means the opposite. Plus is negative. Okay. So on the right side, just ignore first. We will do later on here. And then now you multiply numerator, denominator. So it's going to be 1 minus sine u over, so this is 1 times 1 is 1, and sine u times sine u is sine squared of u, and negative and plus is negative. Now looks, it's closer to this. So that's the manipulation trick I want to. So now equals to dx. Remember, there is du here, don't forget. Du, it belongs to all of them, right? Let me fix it this du. Remember, du is from the top, yeah, here, and then I move here with the parenthesis or brackets. Okay, next. So this is here, double bracket, and this at the outside, right? So I'm gonna make it better. Make it nice. Okay, and there you go. So just make it red. Okay, red, same color with this. This is red and this red. And then I'm gonna put there is the du. Okay, so this must be du. Okay, next, and then they are already into proper position, u, and then you're gonna do integration both sides. Integrate. So 1 sine minus 1 minus sine square u is, from this you can find it, is 1 minus cos square x, right? If you want to find this, it means 1 minus this, right? So you can replace this as cos square u. Yeah? Cos square u is 1 minus this. Alright, so 1 minus sine u on the top still, and put the bracket du equals integral of dx, cancel is x, and because it's infinite, so x plus c. Okay, so I'm gonna separate this because this is divide this and minus this divide this, right? Okay, so I'm gonna separate them. 1 over cos square u minus sine u cos square u du equals to x plus c. Okay, so I'm gonna separate one by one. Integral of cos square u minus integral sine cos square u And don't forget here du, and this is du from this, because this brackets. Okay, equals to x plus c. Now, integrate of cosine square u, if you look to the formula booklet, is actually same with tangent of u, because this into variable u, minus, and on here, this is the tricky one that you need to think. So because this is power of 2, and cosine actually can be extended to, let's say, I want to put this as another variable. So you, let's see, okay, v equals to cos u. So if v square is gonna be cos square u, right? So I'm gonna derivate this one. So dv equal d cos u. So dv equal derivative of cos is negative sine u. Okay, and then don't forget the du, because you derivative respect to variable u. Du here, okay? Negative sine du. Okay, now if you take a look here, sine cos. Oops, don't forget the u here. Oops. So sine u du, look here. Sine u du. Here, same, right? And you just move the negative to this one. So negative dv is actually sine u du. So you can replace this as this, because this is the value of negative dv. So this and this is negative dv. All right, I'm gonna this one, this, okay? This one that we need to solve here. What's gonna be? All right, so I'm gonna just use this space. So on here, let me put it on the left side, more details. So now integral of this is tangent, right? Oops, why do I have integral here? Tangent of u minus. So integral sine u du is negative dv. So negative dv cos squared u. Cos squared u. Okay, so cos squared u is this, right? V square. So now we can have it into same variable on this part. So integral v square, this one, v square, negative, just put negative here, du. This negative, right? Now, so tangent u. Now you have tangent u minus, just put here plus, integrate v squared du. Oops, sorry. Let's check again. There's something wrong. Oh, I bring this on the top. So the power must be changed, this negative, because this positive. Okay, so this must be negative. If negative 1, so negative 1. This is negative 2, this is negative 2. Okay, so negative. Okay, now I still have tangent of u and plus. This is the integral of this, because this is v, this is, oh, this is already dv. dv, yeah, I changed already dv. Make it good. dv. Okay, now integral of this is 1 over negative 2 plus 1 v negative 2 plus 1, and then plus. and then this is negative 1, v negative 1. This is tangent u. Okay, so now negative times positive is negative. Negative v to the power negative 1 is 1 over v tangent u. Okay, remember u, who is variable v. Okay, so u is before x plus y, right? From the beginning. Yes, 1. U is x plus y. And the other one, v negative power 1 is cos negative power 1. So if this is positive, this must be positive. So this is tangent x plus y minus 1 over cos u. Who is u? X plus y. Okay. X plus y minus 1 cos x plus y. But 1 over cos sine actually is secant. How to remember this? Just remember cos secant is like continuing. So 1 over cos secant is secant. 1 over secant is cosine. And 1 over sine is actually same with cosecant. 1 over cosecant is sine. So this is the opposite of this. Okay? So continue to here. So now we have this 1 over cosine is actually cosine is actually secant. So negative secant x plus y. There you go. So if you, this is the, oh yeah, this is on the left side. So on the right side, this, don't forget on the right side, you have to put it x equals x plus y. S. Make it better. X plus c. And then you can put what coordinate it's gonna be through this this equation. This is the equation from the differential equation. This is the first function, the original function, this one. So if you have the coordinate x, y, just insert and then you get the c and find the c, and then if you find another coordinate, just insert. Okay, all right, thank you.